Very good morning, students. Today we are going to learn a new topic, continuity. So before starting this continuity, first let us understand what is limit. So already we have learned what is the limit factor. So we know that when the limit is going to exist, when limit x tends to a minus f of x is equal to limit x tends to a plus f of x. It means that if left hand limit is equal to right hand limit, then we can say that limit is going to exist. So limit will play a crucial role in the continuity function. Now look at here, a function. So in continuity we have two points to be remembered. First we will talk about continuity at a point. Continuity at a point. A function is said to be continuous at a point, then limit x tends to a, f of x is equal to f of a. Or else we can say that left hand limit is equal to right hand limit is equal to the functional value, which is f of a. So to understand better, let us draw the graph. So let us suppose this is a. So here if you observe here, so here in this case left hand limit and right hand limit. Left hand, this graph is approaching towards this point and this graph is also approaching towards this point. It means that the limit is going to exist. Why? Because the left hand limit is equal to the right hand limit. And moreover, here there is a break point. So to fulfill this break point, if I am considering a point A here, if I am considering a point A, and if I am joining this curve, so this curve is going to become now it is a continuous curve. So it is going to become a continuous curve since the function is going to satisfy the value of a. So I can say that left hand limit is equal to right hand limit as well as the functional value. If these three things are equal, then I can say that that particular function is continuous at a point. So here we are taking a single point. So at this point the function is continuous. Now, let us take a few diagrams to understand better. Next, the opposite of this is discontinuous. If suppose f of x is a function which is not continuous, then it will be discontinuous. So if a function, if you are saying it is a not continuous means, then you can use the word as discontinuous. Now let us see this by some graphically. Now look at here. I'll take the first graph. At A. If you observe this three graphs, if you see here, it is a continuous, there is no break at all, so we can say that this graph is continuous at A. Continuous at the value A. Here if you observe here, left hand limit as well as the right hand limit are approaching towards this point, but here it is showing a break. So we can say that this graph is discontinuous. Next, if you observe this third graph, here left hand limit and right hand limit are not at all equal. So left hand limit is not equal to right hand limit, then limit does not exist. If limit does not exist, then the function will not be continuous. And moreover, here the point continuity point is existing, but left hand limit is not equal to right hand limit. So this function we can call it as discontinuous function. So this is about the continuity and discontinuity. Now we will talk about continuous at a closed interval. Continuity at a point we have done now. Now continuity at a closed interval. Or else we can use continuity at interval. Let f of x be a function. Let f of x be defined at a closed interval a comma b, which belongs to rational numbers, real numbers. So let f of x be defined at a comma b belongs to R number. So it is going to be continuous if there are three conditions here. Limit x tends to, let me draw the graph first. So here I need to take the continuity at an interval, means from one point to another point we need to take. So let us assume that this is a point A, this is a point B, and let me draw a graph over here. Now if you observe this graph, here from A to B interval it is continuous. So to exist that whether this is continuous at the from this point to this point, means from this interval, then there will be some conditions here. Look at here. Limit x tends to a minus left hand limit will be equal to f of x is equal to a. So we can write as f of a. Next, limit x tends to b minus, okay, b plus from the f of x is equal to f of b. Or else we can write it as a and b. A value square b value. So from left hand side, means if I want to call it as left hand limit, means here it should be existing, and at this point also it should be existing. Next, at any middle point, let us give the point as x naught. So limit x tends to x naught, f of x value must be equal to f of x naught. Then we can say that this particular function is continuous in this interval. So the left hand limit value must be this a value and right hand limit value must be b value. Then we can say that, and the functional means from here to here if you substitute any value you need to get the given functional value. Then we can say that this function is continuous in this interval. Next, let us learn about the reasons for discontinuity. So there are various reasons for discontinuity. Will be explained by using a graph. Look at here. Limit of first point at point A. We are checking at point A. If you are checking at point A, if you look at your left hand limit is in this approaching this point, but right hand limit is not at all approaching. So your left hand limit is not equal to right hand limit. Left hand limit is not equal to right hand limit. So since left hand limit is not equal to right hand limit, the limit does not exist, as well as the function will be discontinuous. So this is about at point A. Next, second, at point B. If you look at point B, so from left hand limit the function is okay, and from right hand limit also it is equal. So left hand limit and right hand limit both are equal. But when it comes to the functional point at point B, means left hand limit is equal to right hand limit, but at B it is discontinuous. At point B, the function will be discontinuous. Since it is there, circle is there, so we can say that it is discontinuous. So here left hand limit and right hand limit are not equal, that's why it is discontinuous. Here left hand limit, right hand limit both are equal, but it is having a break. That's the reason we can say that it is discontinuous. Now here, in this function, if you look at here from left hand side, it is approaching. From right hand side, it is approaching. So left hand limit exists, right hand limit exists. Left hand limit exists, right hand limit exists, but the functional value is also existing at point C. At point C, left hand limit exists, right hand limit exists, as well as the functional value is also existing. So we can say that left hand limit is equal to right hand limit and functional value f of C is equal to C. So functional value is also existing, left hand limit is equal to right hand limit, but these three are not equal. So left hand limit is equal to right hand limit, but not equal to the functional value which is f of C. So that's why we are calling these are discontinuous. So these are the three reasons for discontinuity. Okay, next let us learn about two types of discontinuity. Removable discontinuity. Removable discontinuity. If a function, if f of x is a function, if f of x is a function with removable discontinuity, removable discontinuity. So if I want to call a function as a removable discontinuity, means the limit value, limit x tends to a f of x should not be equal to f of a value. Means the functional value and the limit value, if they are not equal, then we can call it as a removable discontinuity. Next, the second one is jump continuity. We have the second one as jump continuity. So if f of x is a function with jump continuity, so if f of x is a function with jump continuity, then the condition should be limit x tends to a minus f of x is not equal to limit x tends to a plus f of x. It means that left hand limit must not be equal to right hand limit. Then in that case I can call this as a jump continuity. So jump discontinuity. And here removable discontinuity. Discontinuity. Now we will see about some algebraic terms. So the first one is constant function. So any constant function is continuous. Any constant function is continuous for all real values. For all real values. Next, modulus function. So whenever a modulus function is there and it is asking us to check whether this function is continuous or not. So we can say that any modulus function is continuous. Any modulus function is continuous from R to R values. Any real numbers will be continuous. Okay, if we take any exponential functions, so any exponential function is continuous. So for example, exponential means you can take f of x is equal to a power 6. So it is having the power 6. So if you substitute any values also, in place of a, the function will be continuous. So the next one is polynomial function. So polynomial function, all polynomial functions are continuous. All polynomial functions, so it will be the form of f of x is equal to a naught x power 1 plus a1 x1 plus a2 x to the power of n minus 1 plus n minus 2 plus so on plus an. So this function is also continuous for all real numbers, for all the real numbers, and here also this function is continuous for all the real numbers. Next, the fifth function is root function. We can write it as nth root. Nth root function. Any root function is continuous. Based on the interval. So based on the interval they are continuous. For example, let us take a function f of x is equal to root x. So if we substitute the positive values x greater than or equal to 0, so all the values which are greater than or equal to 0, the function will be continuous. Next. So quotient polynomial. Quotient polynomial. So all quotient polynomials are continuous. All quotient polynomials are continuous. So that is p of x by g of x. We are going to get as q of x. So dividing one polynomial by another polynomial, we will get a polynomial which is quotient polynomial. So it is continuous for all the real numbers. R belongs to R. Look at this exercise 9.5 first question. Prove that f of x is 2x square plus 3x minus 5 is continuous at point R. So by seeing this we can say that it is a polynomial function. So given f of x is equal to 2x square plus 3x minus 5. So here f of x is a polynomial. We know that polynomial functions are continuous. So polynomial functions are continuous, therefore f of x is continuous for all points on all points R. All the real numbers will be continuous. Okay, here domain will be negative infinite to positive infinite. Open and out negative infinite to positive infinite. Next, let us see the second please. So in the second bit, examine the continuity of. Let us see the first question. Examine the continuity. We need to check whether it is continuous or not. Examine the continuity. So the following function, the first function is x plus sin x. So let us write the answer here. Given f of x function is x plus sin x. So here x is a polynomial which is continuous. Which is continuous, and sin x is a continuous graph. We know that the sin x graph is very continuous. So like the sin x graph will be that it is continuous. So by seeing this we can see that therefore both x and sin x are continuous. So f of x is continuous. Let us see another question. Fourth question. E power 2x plus x square. So answer, given function f of x is equals to e power 2x plus x square. So it is exponential function. We have the formula 1 plus x by 1 factorial, that is 2x plus 2x square by 2 factorial plus 2x cube by 3 factorial plus so on plus x square. So this becomes a polynomial now. So here from here it is a polynomial and this is also a polynomial. So polynomial functions are continuous. Polynomial functions are continuous. So we can say that therefore, so we can say f of x is continuous. F of x is continuous for all the real numbers. Next, let us see the next question. Seventh question. X square minus 16 by x plus 4. So it is a polynomial function. Answer, given f of x is x square minus 16 by x plus 4, which is a polynomial function. Here the domain will be all the real numbers except minus 4. Why? Because if I substitute minus 4, it will be not different function. So domain will be all the real numbers except the minus 4 number. Here the above is a polynomial. The above is a polynomial. So polynomials are continuous. Polynomial function is continuous. Therefore, f of x is also continuous. Continuous from R, but except minus 4. Except minus 4, remaining at all the points will be continuous. Now let us see the third equation. So third bit first question. So it is asking that find the points of discontinuity. Where the point is discontinuous, where we need to find out. So given f of x is equal to 4x plus 5, x is greater than or equal to 3, 4x minus 5, x less than 3. So here it is x less than or equal to 3, here it is x greater than 3. Now, these are the two given functions. We need to check the discontinuity of this function. Now, let us see. So, if you observe here, greater than 3 is there and less than 3 is there. So, we need to check which value. So, the values are greater than 3, more than 3 as well as less than 3. So, 3 will be the continuous point. So, we need to check whether at the 3 it is continuous or not. At continuity point 3. So we are going to check at point 3 whether it is continuity or not. So if we want to check 3, let me substitute 3 value in the given function, which is f of x limit x tends to 3 f of x. That is equal to, if I want to substitute 3, so here it is possible. So that is 4 into 3 plus 5, which is 12 plus 5, which is 17. So here continuity answer we got as 17. So next let us check it for left hand limit and right hand limit. At left hand limit, that is limit x tends to 3 minus f of x is equal to. So 3 minus 3 is less than 3. The function is 4x plus 5. So the value is 3. So 4 3 is 12, 12 plus 5 17. So at right hand limit x tends to 3 plus, so more than 3. So more than 3 is the functional value 4x minus 5. So 4 3 is 12, 12 minus 5 7. Here if you observe here, left hand limit is not equal to right hand limit. Left hand limit is not equal to right hand limit. So we can say this is a jump discontinuity. Jump discontinuity. So we can call this as a jump discontinuity at x is equal to 3.